Okay, so today I'm going to do law of sines. This is a quick jot of the notes down. There's going to be another side of notes that I'm going to explain up here. But what we have is law of sines is little a over sine of a is equal to little b over sine of b, capital B and capital A, sorry, equals little c over sine of big C. Now, small a, b, and c, the small ones, all on top, those are the side lengths of our triangle. And then big A, big B, and big C, those are the angles of our triangle, okay? So, I have two triangles here, and this is what we're looking at. If A is an acute angle, okay, it's A, B, and C, B, and C, and A. So you can see, there's kind of a pattern. Whatever you decide to make your angle A, whatever that angle is, the side opposite of it relates to it in terms of our proportion. As you can see, little a, big B, big C, little c. Same thing if I come over to where A is obtuse. Let me write that up here, sorry. A is obtuse. Alright, you can see, again, right angles on there, outside of it, so it's our height. I'm going to talk about the height after this little slide. So big A, small a, big B, small b, big C, small c, okay? So we're going to do a lot with this proportion. This is the main idea in understanding how this triangle works. And we're going to do some examples with it. And pretty much it's just cross multiplying, which is pretty basic in terms of mathematical properties when you're dealing with trig. So if you need to pause it to jot down the notes, pause the video, I pause it on the video and make sure you get that down, and I'll be back. Okay, so I mentioned earlier some special cases with law of sines, and again, I'm going to go over some examples, but first let me get all kind of the important notes and details that you kind of need. We're going to consider a case, a triangle, in which we're given small a, small b, and big A. And besides that, we have this little formula where h, the height, equals little b times sine of a. Okay, that's going to come important in terms of what all these little triangles mean. Now there's another set which I'll draw up once I'm done explaining these, but when a is acute, alright, if we have these type of scenarios when we're given those three parts, we have where if a is less than h, or small a is less than h, we have no solutions to the triangle. That means there's no triangle available. Alright? When a equals h, we only have one solution to a triangle. Another one is when a is less than or equal to b. So when little a is less than or equal to b, we have one solution to the triangle. This is one of the trickier cases with it. When h is less than a, but a is less than b. So h is less than a and a is less than b. We get this kind of triangle right here. That means we have two different types of triangles available. So what that means, we'll get two different types of angles and two different answers for A. And it takes a little bit more work. I'll show an example of this whenever I start doing examples, but I just want to be clear to this. So what I suggest to all my students whenever doing these type of problems, you see H is involved in at least three of them. Find H. Just go ahead and find it. You're given these three. H takes no time to find. Go ahead and find it so you know which kind of triangle you're dealing with. So you can say, hey, no solutions. Boom, easy. Or hey, I'm only going to have one, or the big one, I'm going to have two, so I need to make note of that. Alright, so again, I highly suggest that if you need to take the notes of the triangles, pause it right here, get them down so you understand what's going on. I'm going to draw up the obtuse ones right now. Okay, let me continue with those special triangle cases. So I still have, if we have a considered triangle, which given where small a, small b, and big A, where h equals b sine of a, again, that plays more important to when a is acute. Just when a is obtuse, though, we have two other type of triangles. When small a is less than or equal to b, small b, we have no solutions. So boom, you're done. And then one solution is if a, small a, is bigger than B, we have one solution. Now this is again when A is an obtuse angle. Just something to look out for whenever doing these types of problems. So again, if you need to pause it and see where these notes are at, or write down the notes, go ahead. In the trig book that my class uses, it's on page 430. So. Okay, here's our first example of that I'm going to do with you guys. So I just wrote down my formula because that's what I'm going to use. I also wrote my H equals B, sine of A on the side, in case it comes up. So that way we're aware of it. Right now, we don't have A. So what I like to do, let's look what I need to find. I need to find the angle big A, little c, and little a. Now of course, if I'm given two angles, hopefully you should be able to find angle A, because how many degrees are in a triangle? It's 180. You should know that by now. So all we need to do is go to find big A. That equals 180 minus 105 plus 45. Alright, and that's, of course, I can't do mental math. Equals 30. Again, that is something everyone should be able to do. Alright, so now let's just pick one. Oh, let's go find little a. Or actually, let's go find little c. So I want to find little c. If I look at my formula, I'm going to use this proportion the entire time doing law of sines. So let's plug in what I have. If you see, they're all equal to each other. So if I just take two of them and plug them in, that's all I need. I don't need all three to find the answer. I only need two of them at least to get part of it. So if I plug it in, I got 20, because that's our size for small b, equals sine of 45, because that's our angle there, okay? So then that equals little c, that's what we want to find, over sine of 105. So that's what we get, cross multiply. It's one of those simple things. Or you don't even need to cross multiply, I need to get c by itself. That's what I need to get together. So all I'm going to do is multiply both sides by 105. Just go erase that. By sine 105. Alright, so that means I'm going to multiply the top. So that means I get 20 . Sine 105 all over sine 45 will give me little c. So let's use our calculator, plug that in. Make sure you guys use parentheses correctly. If you have a graphing calculator, it's going to do this. Go ahead and put parentheses around that. What I also do is put parentheses around the whole thing. Most graphing calculators, anyways, in my experience, do that. And what I get is 27.32. Remember, your mode should be in degrees because you're dealing with degrees. You're not dealing with any radians now. So that's our answer to C. What do we need to find little a now? So I'm going to come over here, leave that over there. It's the same process. All right. So little a. Use the angle 30, sine of 30. Now, of course, you could use your answer you got for little c and do sine of 105. I don't like doing that. I like using the information that it already gave us. So what I'm going to do the same thing as 20 over sine of 45. Okay? Cross multiply again if you want to. Otherwise, sine of 30, top and bottom. So it means we get 20 sine 30 all over sine 45. Plug that in our calculator. And we get 14.14. 4. If I check my answer book, exactly what they got. Okay? So that's an example of how to do it. A pretty basic one. Given the image, use the formula, go. So let me erase this. Let's get more complicated, I guess, or one that's not so straightforward. Alright, so let's So that's what we got right here. No image. So, if they're just given this, draw an image. I think it's easier to just draw the triangle, that way you know what you're looking for. And you know how to set up your equation. So, just do a quick sketch. And you can see A is still acute. That's my A. Across from it is little a. Alright, if we looked at our picture before, this is our C, this is our B. So A, B, C. Across from C is little c, across from B is little b. Sorry. This throws off students a lot, I've noticed. It's 83 degrees in 20 minutes. All you need to do, get this in degrees, so divide this, the 20, just the 20, by 60. And because there's 60 minutes, so therefore this whole thing now equals 83.33 degrees. Shouldn't be that complicated to do that, okay? How I got this number again. Take this, 20 divided by 60, gets you that portion, okay? You just add it to it. So now that I have that, I need to find big B, small b, and little a. Alright, so let's go do that. Big B is easy again to find because I have two angles. So it's 180 minus, okay, 83.333 minus 54.6. Or sorry, this should be plus right here, plus 54.6. Like that. And you should get a nice 42.07 degrees. Okay? Again, if you're given two angles, to find the third angle of the triangle, it's very simple. Okay? Now, let's go find little a. So to find little a, that means I'm going to use A over sine of 83.3 equals 18.1 over sine of 54.6. Alright, so let's go ahead and we don't need to cross multiply it. All I need to do is multiply top and bottom. Multiply both sides by sine of 83.3 to where I get 18.1 sine of 83.3 all over sine 54.6. Again, let's just plug that in your calculator. I get 21 21.93. So that's my little a. Let me check, make sure I got that right. And of course, it depends on where you start rounding your answer to. So it all depends on where you start rounding stuff as well. So let's get little b. So it's just b over sine 42.07 equals, let's use c again. I want to use c because that's what I was originally given. Alright, so I multiply everything by sine of 42.07 again. And that's what I get there. Alright, so let's go ahead and plug that in your calculator again. Alright, enter. And we have to move. I get this 14.79. So there is our three answers, and if we look, A is greater than B. So if we go back to those special cases, just to make sure, just to check, which I went over earlier, when A is greater than B, we only have one solution. So that's how you solve those ones, only have like that. I'm going to do one more example, and I'm going to do, I'm going to do one with two examples, so let's do one of those. Okay, so we're given this information. Big A is 58 degrees, little a is 11.4, and little b is 12.8. If I go back to, I get one of some special cases of what it gives us when a is a cube. So if you wrote those down, when we go back, if a was less than b, we'd have no solution if this was an obtuse angle, but it's an acute angle. But the deal is we do know A is less than B. So what we need to do, let's go find H. Just so we can have it. Again, H is equal to B, little b times sine of A. So I'm going to go find that real quick. So I'm going to say H is 12.8 sine of 58 degrees. And this is to confirm that H will be lower, lower than A, which it is. From here we get 10.85. All right, so it's lower. So let's find the rest of it. I'm going to draw the triangle. That wrong. And that's the triangle that I'm going to have, roughly, okay? It's not drawn to scale, but that's the triangle I have. What I need to find is this, all right? I have two A's, I believe so. Well, I'm gonna, oh, so sorry. This is C, and this is C. Okay, so basically this is what I have in terms of my triangle, because A stays the same. At least I believe so. I'm not even gonna do that. What I know, well, let's draw the triangle. Kind of is a little tricky. So what I'm gonna do is just go with this. I need to find. I know I have two solutions. All right. I know I'm going to have two solutions. So, because of that property where H is less than A, but A is less than B. So I know I have two solutions to this triangle. And so the first thing that I like to do is let's find my other angle, angle B. Let's do that. Plug in what we have. So I'm going to find big B. All right, so that's equal to 11.4 sine of 58 equals 12.8 sine of capital B. Okay, so that's what we need to find. And how we do that one is, it's a little bit different. I want to get sine of B by itself. So this time I am going to cross multiply, just so you guys can see what an easier way to do it. And we get 11.4 sine B equals 12.8 sine of 58. I'm going to divide by 11.4. Alright, so let's go ahead, and that's what we get. Let's go ahead and get a number for that. Get a nice decimal. And we get sine of B equals 0.952. Alright, now hopefully you guys remember to get an angle measure, if I have that, take the inverse of it. So B, capital B, big B, sine negative 1, 0.952. Alright? And I get, originally, you'll just get this. 72.21. So that's one solution. Remember, we have two solutions. So all you got to do, what I do, is subtract that from 180. So go 180 minus subtract that from 180, so we get our other angle. Because think of a sine, if you remember how we do that, sine on our degrees goes from here to here in terms of sine inverse, our range, our domain. So if it's on this side, subtract it and I get that other side to it. Alright, so if we do that, again, one solution. So I'm going to call that B1, B2. That equals 180 minus 72.21. And that's going to equal 107.79. Alright, so that's our answer for B2. Alright, so we have B1, 72.21, and B2 equals 107.79. So I'm going to write that up right here real quick so I can erase it so I have room. Alright, so that's that first part. Alright, so that's that. Now we need to find C1 and C2. Remember, big C, big C, big C, and for both sides, sorry, big C1, big C2. So basically, that's just 180 minus our A, because A doesn't change, 58 plus B1. Alright, so let's go ahead and do that. 58 plus 72.21 minus 180. We should get, it's going to be 49.79. So that's our answer for C1. For C2, it's kind of the same thing. 180 minus 58 plus B2. And that's going to give us 14.21. So those are answers for C1 and C2. So I'm going to go ahead and write that over here as well. So we're almost done. We got almost all our answers. We just need to find little c. All right. For both triangles, remember we have two triangles. So little c1, and to get that, we're going to go back to our line and sine properties and just use some ratios because we have angles now. So basically, we're going to use 11.4 over sine of 58. Equals little c1 over sine of 49.79. Because remember, we're solving for c1, so we're going to use angle of c1 to do it. So basically, we're going to get 11.4 sine of 49.79 equals sine 58, plug that into our calculator. We get 10.26, I believe. I'm going to double check. Yeah, 10.62. So that's our answer for little c1. Now, if we want to find little c2, it's kind of the same thing when you think about it. It's all that changes is this degree right here, because it's 11.4 sine 58 equals c2 all over sine 14.21 now. So basically, we're doing the same steps we did before. Alright, so let's plug that into our calculator real quick. And that gets us a nice small number of 3.29. Alright, so those are answers for little c1 and little c2. Again, I erased this stuff, but we have two solutions because we had to find this, because we have to remember h less than a less than b means we have two solutions. 10.285 is less than 11.4, which is less than 12.8, when capital A is a cube. So there's an example of finding two solutions. Now, basically, that's all you do to find law of sines. The same steps over and over and over again, cross multiply, and you can go from there. There may be some other tricky stuff, some word problems, stuff like that, but in terms of difficulty of problems, they're really not that difficult when you actually think about it. There's another part, because on my part, this is 6.1 from the pre-calc trade book that I teach from. There's a thing called area, as well as oblique triangle. I'm not going to show examples of those because that is actually very simple as well. You just use your triangles and plug in what you have, because usually they give you what you have. So, hopefully that helps for anyone who's doing law of sines and needs help.